Page 14 of exponentials. Draw freehand sketches of the following pairs of graphs using your observations from the Desmos investigation. Okay, so let's go to A. It says to draw two graphs. One is y equals 2 to the x, and the other is y equals 2 to the x minus 2. Okay, so first we're going to look at y equals 2 to the x, which is kind of a standard function that is not transformed in any way. So we're going to make a little xy table to graph this one. If we put in x equals -1, then we're going to get 1/2 because 2 to the -1 is 1/2. If we put x equals 0, we're going to get 2 to the 0, which is 1. If we put 1, we're going to get 2 to the 1, which is 2. And if we put 2, we're going to get 2 squared, which is 4. Okay, so I'm going to graph this. I'll write the x, y axes like that. And then I'm going to graph some of the points. So -1, 1/2 would be here. 0, 1 would be here. 1, 2 is here. And 2, 4 is here, right? So the original function, which we'll draw in green, looks kind of like this. Okay? And then we have the other function, which is basically the parent function, and then it has -2 at the end. Okay, so how does this -2 affect it? If you remember from the investigation, putting a plus c value here just changes the x-intercept. It shifts the whole thing up and down. But if you don't trust me, what you can do is you can build out a table just like we did there, except now we're going to put, it's going to be adjusted by -2. So put -1 in there, it's going to give me 1/2 for the first part, then I'm going to subtract 2, so it's going to give me -3/2. If I put 0 in here, it's going to give me 2 to the 0, which is 1, minus 2 is -1. If I put in 1, it'll be 2 to the first, which is 2, minus 2, which is 0. And if I put in 2, it's going to be 2 squared, which is 4, minus 2, which is 2. If I put in 3, it's going to be 2 to the 2 cubed, which is 8, minus 2, which is 6. Okay, now I'm going to graph these. So I got -1, -3/2, it would be about here. I got 0, -1, it would be here. 1, 0, it's here. And you can see it's starting to make a pattern. 2, 2 is here. You see how like every single point is simply 2 units below the points on the green graph. Finally, 3, 6 would be here. Okay, and then I'm going to graph it using blue. So you can see that the blue graph is simply the green graph, and every single point is lowered by 2 units. Okay, so basically we have confirmed, just like we did in the investigation, that the plus c value here basically adjusts the height of the whole function's graph without really changing the shape. Let's move on to the next one. The first thing it tells us to graph is the parent function again, so I just regraphed it here in green. Then it asked us to graph the parent function times 2. So let's make the xy table again. Okay, and so we'll put in the numbers -0, 1, and 2 in for x, and then we'll see what we'll get out for y. So if we put a -1 in for x, we'll get 2 to the -1, which is 1/2, times 2, which is 1. If we put in 0 in, we get 2 to the 0, which is 1, times 2, which is 2. If we put 1 in, 2 to the 1 is 2, times 2 is 4. And if we put 2 in for x, we get 2 squared, which is 4, times 2, which is 8. Okay, now let's graph these points. So we got -1, I'll do these in blue, -1, 1, it would be here actually. 0, 2, it would be here. 1, 4, it would be here. 2, 8, 2, 4, 6, it would be about here. So you may not see exactly what's going on here, but if you mark the points like that, you can see that every time I have the original green point, the original green point is doubled so that the blue one is kind of stretched vertically, right? So that's basically what happens when you put a new value there. One of the things that is adjusted when you do that is the initial value. The initial value you see, instead of being 1 now, is now 2. Okay? And if you remember in the investigation, that's what we discovered, that the number here controls the initial quantity of the bacteria. Number 5, draw freehand sketches of the following pairs of graphs. So here we'll do y equals 3 to the x. First we'll make a table. We'll put in values -1, 0, 1, 2 for x. If we put in -1 for 3 to the x, we're going to get 1/3. If we put 0 in, we're going to get 1. If we put 1 in, we're going to get 3. And if we put 2 in, we're going to get 9. Let's draw. Okay, and then I'll put in the points. -1, 1/3, about there. 0, 1, 1, 3, 2, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then I'll color it in green. Okay, then it says graph 3 to the negative x. If you remember from the investigation, 3 to the negative x basically is going to reflect it about the y-axis. But just to confirm, we'll go ahead and we'll put in similar values here. Okay, so if we put -2 in there, we're going to get 3 to the -2, which is 3 to the 2, which is 9. If we put -1 in there, we're going to get 3 to the -1, which is 3 to the 1, which is 3. If we put 0 in, we're going to get 1. If we put 1 in, we're going to get 3 to the -1 is 1/3. If we put 2 in, we're going to get 3 to the -2, which is 1/9. Okay, so we're going to graph that. So it's going to be -2, 9, -1, 3, 0, 1, 1, 1/3, and 2, 1/9 is very small. Okay, so I'm going to put a curve through that. And you can see that I've just reflected it about the y-axis, right? Okay. In B, I basically have the parent function, which is 3 to the x, and then I'm drawing the new function, which is 3 to the x plus 1. Okay, and the only difference between 3 to the x and 3 to the x plus 1 is every single value that we graphed for 3 to the x is going to be raised 1 unit. Okay, so I don't even need to make an xy table. I could just take each one of the graphing points and I could raise them by 1 unit. And that's going to be the new graph, which is 3 to the x plus 1, right? Basically looks like that. Okay? All right. 6. For each of the functions below, which are these two, sketch the graph of the function, state the domain and range, use your calculator to find the value of y when x equals the square root of 2, discuss the behavior of y as x goes to plus or minus infinity, and determine the horizontal asymptotes. Okay, so first we'll do this function, 2 minus 2 to the x. I'm going to make an xy table, and I'm going to graph -2, 0, -1, 0, 1, and 2. So if I put -2 in there, I'm going to get 2 minus 2 to the -2. 2 to the -2 is 1/4. 2 minus 1/4 is 1.75. If I put -1 in there, I'm going to get 2 minus 2 to the -1, which is 2 minus 1/2. That's 1.5. If I put 0 in there, it's going to be 2 minus 1, which is 1. If I put 1 in there, it's going to be 2 minus 2 to the first. 2 minus 2 is 0. If I put 2 in there, it's going to be 2 minus 2 squared, which is 2 minus 4, which is negative 2. If I put 3 in there, it's going to be 2 minus 2 cubed, which is 2 minus 8, which is negative 6. Okay, now I'm going to draw the axes for this. And so since I have some positive values and I have some negative values, I'm going to draw it maybe like that. And then so the first point is negative 2 comma 1.75, so it's about there. Second point is negative 1 comma 1.5, it's about there. 0 comma 1 is here. 1 comma 0 is here. 2 comma negative 2 is here. And 3 comma negative 6 is here. Okay, so I'm going to sketch this out. I'm going to connect these. Oh, I'm going to use green like I did before. Okay, so it looks kind of like that. Let's see what other questions it asks us. State the domain and range. Okay, so in the case of the domain, we have to consider that this function actually like goes on forever in both of these directions. The range itself is basically like the valid x's, right? It obviously goes infinitely to the left. Now what about to the right? Does it go infinitely to the right? Yeah, actually it does. It like goes infinitely this way and infinitely that way. There is no asymptote for the exponential function, no matter how it might look like it might have a vertical asymptote. It does not, okay? Vertical asymptotes arise because there's a 0 in the denominator, no 0 in the denominator here, right? Okay, so for the domain and range, I'm going to say the domain is x is all real numbers. For the range, I'm going to say looks like it exists from this point down. This is the y equals 2 line, okay? So I'm going to say that it's y is less than 2. Am I going to say it's y is less than or equal to 2 or y is less than 2? Well, it never actually touches 2 because that's the asymptote, so it's y is less than 2. Okay, and actually it does ask about the horizontal asymptote. The horizontal asymptote is y equals 2. So those are two related things. The range and the horizontal asymptote are related. Use your calculator to find the values of y when x equals square root of 2. And then I'll go back and do that. And discuss the behavior of y as x goes to infinity, positive infinity, or negative infinity. Okay, so what happens to the graph as we go infinitely to the right? Well, it goes infinitely down, okay, because there is no asymptote. So we'll say as x goes to positive infinity, y goes to negative infinity. What about when x goes to negative infinity? When x goes to negative infinity, y approaches the asymptote, which is 2, and it approaches 2 from the bottom. Okay. Determine the horizontal asymptote. We already did that. Okay, so now let's bring in the calculator. Now I'm going to go back and use my calculator to find the value of y when x equals square root of 2. So I'm going to put in the function, which is 2 minus 2 to the x. 2 minus 2 to the x. And instead of x, I'm going to put in square root of 2. So the value is negative 0.665. And I'll say here, 2 minus 2 to the square root of 2 is equal to negative 0.665. I'm not sure why they asked us that. It's very off the wall. Okay, next one we're going to do is this one here. 2 to the negative x, remember, is like exponential function that's flipped the other way. It's like flipped that way. And then plus 3 kind of raises it 3. So let's do the xy coordinates just in case. So we're going to put in a few values here. So putting in negative 2, we're going to get 2 to the negative 2, which is 2 squared, which is 4, plus 3, which is 7. If we put in negative 1, we get 2 to the negative 1, which is 2 to the 1, which is 2, plus 3 is 5. If we put in 0, we get 2 to the 0, which is 1, plus 3, which is 4. If we put in 1, we get 2 to the negative 1, which is 1/2, plus 3, which is 3.5. And if we put 2, we're going to get 2 to the negative 2, which is 1/4 plus 3, which is 3.25. And then if we're going to graph these, most of these values are very positive, so we could just like put the x, y axes like that. Negative 2 comma 7 would be here. Negative 1 comma 5 would be here. 0 comma 4 is here. 1 comma 3.5 is here. 3 and then 2 comma 3.25 is here. I'm going to graph this. Okay, I can already see where the asymptote is, right? So first it says state the domain and range. As usual, the domain is all real numbers, right? It goes as far to the left or far to the right as you want. The range is going to depend on the asymptote. It's going to be everything 3 and above. Is it going to include 3? No, because 3 is the asymptote. So the asymptote, horizontal asymptote, is y equals 3. And the range is going to be y is greater than 3, as is obvious from the drawing. Use your calculator to find the value of y when x equals square root of 2. So we're going to put 2 to the negative square root of 2 plus 3. And that's going to give us 3.38. 3.38. That is at x equals square root of 2. Okay. Discuss the behavior of y as x goes to infinity and negative infinity. So as you go to positive infinity, you can see that you approach the asymptote. So as x approaches positive infinity, y approaches the asymptote, which is 3 from the top. As x goes to negative infinity, y just goes to positive infinity. And that's it for this page.